Hi everyone, I'm Cyril Filias, the Learning and Development Specialist at CERIC. Welcome to today's webinar, and on behalf of all the CERIC team, thank you for being so many with us today. Today we are delighted to have Janet Miller, Randy Connolly, and first Michael Uzoka with us, who are the three authors of the recent CERIC guide, Computing Career and Disciplines, a quick guide for prospective students and career advisors. In today's webinar, our presenters will provide you with an overview of the new guide and how to apply it in your work. But before we get started, I would like to take a few moments to introduce you to CERIC, for those of you who don't know us yet, and share some housekeeping notes with you. So CERIC is a charitable organization that focuses on education and research in career counseling and career development in Canada. Our main programs are the careerwise.ca website, where you can find the top news and view in the field. And we have a French website version called orientation.ca. The Careering magazine, which is the Canada's magazine for career development professionals. The Canadian Journal of Career Development, which is a peer-reviewed academic journal. And the Connexus National Career Development Conference held each January. So you can learn more about all the CERIC work and resources at ceric.ca. And because CERIC is always looking at new webinars and learning opportunities for you, we will greatly appreciate you sharing your feedback and future learning needs in the survey that will pop up on your screen at the end of today's webinar. So thank you in advance for your answers. Now, some quick housekeeping notes. So if during today's webinar you have any questions or any comments, please enter them in the question box you see on your screen. Our presenter will address your question throughout the presentation. And also please note that at the end of today's webinar, we will send you a recording of today's webinar along with the presentation slide. Now it's my pleasure to introduce you to our first presenter, Randy Connolly. Randy has been teaching at Montreal University since 1997 and holds the rank of full computing professor. He is the author of 3 textbooks, the most recent of which is used by dozens of students at over 100 universities worldwide. Our second presenter today is Janet Miller. Janet is a counseling psychologist with expertise in mental health, leadership, and post-secondary student success. She has worked at Montreal University for more than 20+ years as a counselor, full professor, and chair support coordinator. And our last and third presenter today is first Michael Uzoka. First, Michael has taught computer science and information system at various universities since 1992. He is a full computing professor and served as research development officer at Montreal University. We want to thank our 3 experts for partnering with us on this new guide and are thrilled to have them with us today. So let's not wait any longer to have them start their presentation. So over to you, Randy.
Oh, hi. Hi. Welcome you all to this webinar. We're going to be talking about how to navigate the computing career pathways in 2020 and tell you what career advisors need to know. And we want to thank very specially CERIC for organizing this webinar and also for sponsoring our research. The research in this domain commenced in 2012. You can imagine how far we have gone, and it has gone through a number of iterations. And the current presentation is our last effort at explaining the computing disciplines properly to career counselors and taking cognizance of the various pathways that students can take or individuals can take in order to become computing professionals. We also want to thank Cyril in a very special way. She has been our technical guru, and she's done a lot of work behind the scene, trying to making sure that everything goes on well. Thank you, Cyril, for all the hard work that you do and for helping us through this seminar at this COVID challenging time. Everybody, anytime you make a comment, you must mention COVID. for now, so I thought I should mention. As indicated earlier on, my name is Faith Michael Uzoka, and I'm a professor at Mount Royal University, specializing in computer science and information systems. And I would now hand over to Professor Janet Miller to introduce herself.
So hi, I'm Dr. Janet Miller. I'm a psychologist and I work at Mount Royal University as well. My role is very different than Randy and Michael's. I am on campus as a therapist to students, and a lot of my work is around career development and career counseling. So that's how I ended up in this project, was to help my students and our prospective students to understand more about these fields. Randy is our other amazing presenter and also the designer of our booklet.
Oh, yes, that's me. Sorry, I got...
It's okay, you're driving the slides as well, Randy.
Right.
Introduce yourself before we get started.
Sorry, say that again.
Say a few words to introduce yourself before we get started.
Well, we've already heard who I am, and I'm in the computing department, colleague of Michael's, and yeah, excited to be here.
Okay, well then let's go through our overview of the 3 things that we plan to talk about in the webinar today that really introduce a booklet that you'll be able to download, and we'll give you all that information through the presentation as well. So our plan is to talk about computing careers today, to give you an understanding of what it is that's out there and some of the things that we think students need to know. We're going to give you a perspective of the different disciplines from the outside, but also from the inside, what again, prospective students might need to know about these careers that might help them to decide to go into these fields. We've revised a booklet through CERIC with their support. Randy has done an incredible design job that tells a story to help illustrate these careers, and that's our plan to help you to understand these careers and disciplines a little bit better to help your clients understand these pathways. Before we get going too far, we've got a little bit audience participation. So Ceriel is going to put up our first poll, and that's to help us understand what role you have. Are you a counselor? Are you an administrator or an educator? Are you working in this field of computing already? If you could give us an idea of what brings you to this webinar in terms of your role, that will help us to be more organized in answering questions and thinking about applications. Oh, I'm excited to see what's going to happen. Who is among us? We have over 500 people on the line, which is fantastic. We know others are joining us as we go. We're curious to know what role you have and what brings you to this webinar. Are you interested in that career counseling perspective? Are you here as an administrator? Are you an educator like Randy and Michael are? Or are you working in this computing field? Ceriel, I don't see answers or the responses to the poll, so if you could share those, that would be great. Oh, there we are. Great. Now I see them. Beautiful. So we don't have a lot of computing experts per se here. We do have a lot of people in that career advisor role and counseling role. So my people, we are a kindred spirit. So we are interested in helping people to design their career pathways and understand more about these different computing fields. We have a few educators in our crowd and a few administrators. Okay, so then our second question is about how knowledgeable are you about these career disciplines? Not at all. Will this be fresh for you? Do you have a little bit of information, a decent amount? Do you understand these computing fields really well, or are you an expert? Is this like, this is your jam, you know this stuff very well and you could co-present with us? Give us an idea of what your knowledge of the computing disciplines are, just again to help us orient and be ready for your questions. Excellent. Again, curious about how knowledgeable do you feel you are about these disciplines? That's great, Ceriel. Thank you. Okay, so we have, most of us are a little bit aware of these computing disciplines. Some of us have, we would say, a decent amount of knowledge. Some of us will be brand new to this, Randy and Michael, so let's go slow as we talk about these different pathways. Some of us know it really well. No one here said excellent, it's my specialty, which makes me a little less nervous, although I gotta say I'm still learning, and I feel like every time I think I know, there's more to learn. So maybe that excellent category is something none of us can actually achieve. Our last question is more of a at-home reflection question. When you think about these computing disciplines, when a client comes into your office to ask about going into a computing field, what's the first word or words that come to mind for you? For me, it was programming. I think about programming, coding, kinds of activities. When I thought about the computing fields, this was first for me. But what I'm learning by working with Michael and Randy and through our different work with the ACM is that there are so many possibilities in this computing area. So while it might be that programmer comes up first for you, it's actually surrounded by a plethora of different kinds of computing fields. And that's what makes it so hard to do career counseling or to be a career advisor with clients in this day and age, because most of our people don't know what they're going into. They think, I'm going to load up and go into computing for programming, when really most students don't understand the disciplines. They don't understand computer engineering versus computer science. They just know they want to be in computing, but maybe don't have a clear understanding of what that could be. When we think about why are they driven there, often it's for jobs, that they want to line up for that opportunity for employment. And we do know that employment is growing in this sector, that especially we talk about COVID, Michael, my goodness, there's so much online. Your field has just been dominating, and we've all been very grateful for the technicians and computer scientists and innovators in our communities. But we know that the employment growth is going to continue to be strong in these fields, but not just programming. It's more complicated than that and more varied. We're excited about that. So most students or career clients, it might not be a brand new student going into university or college, it might be someone transitioning in their career, are curious about how do they get these jobs? How do I go into this opportunity? What should I take? What program? And we all know as advisors, it's not so easy. It's not like you go into one program and you end up with one career that it's not like a pipeline here. It's not that we're putting people into a pipeline and spitting them out into a job. In fact, many times jobs are not even created yet, that this field of computing is ever changing. So the three of us worked with students to understand where they didn't understand. That sentence made no sense. We worked with students to try to research how they understood the career disciplines and where their misunderstandings were, and that led to the creation of this booklet, designed by Randy, informed by Michael and I, and used to support student understanding of the career disciplines. Randy, I'm going to throw it over to you about why we did this, what questions it's answering, and how it might be used in the field.
Yeah. Excuse me. So the book in the second edition was really oriented around sort of three key questions. And so the first question was, well, why should you consider computing when choosing a career? Like, it might seem reasonably obvious, but we were kind of informed by this idea of a counseling sort of research idea around outcome expectancy, that people have a certain expectation about what, like they choose a career and an education path based on what they hope to achieve, right? So they kind of want to, the university experience is the dark spot. That's not very good. But you have this path, you hope to achieve this sort of bright future. And one of the key things that we wanted to really communicate through the booklet and when we advise students who are considering computing is that despite the stereotypes, computing is actually a really social activity. It's predominantly younger people are working in it, and there's actually a lot of creative avenues. So these are really three kind of outcomes that are very attractive to young people. So we tried to capture this just in a single slide or in a single page in the booklet about, well, why should one pick computing, right? It's not just the jobs. There's the social, there's the ability to work anywhere. There's a lot of innovation. There's flexibility, meaning that you can, it's easily adaptable to parenthood, for instance. You can work at home, as we've all discovered, right? You can have different types of hours. And a computing career tends to have a real variety over the course of one's life. And I think that's actually also a really attractive feature. The second key question that we wanted to look at in the book is, well, what kind of computing jobs are out there? Well, there's a lot of different types of computing work out there. We group them into 6 different categories: infrastructure work, data work, design work, development work, business, and management, and then tried to provide some job categories. We often, if we don't know much about computing, there's a tendency to think about just the development, that it's all about development. But no, it's actually just one of the floors of the sort of the complete building, if you will, of computing. So then, of course, the question is, well, what kind of pathways can one take? How do I get there, right? You've got this destination that you're trying to achieve. How do you get there? So our thinking on this answer was focused on the ACM computing disciplines. So computer science is what we tend to think of as the default computing discipline, but it's just one of them. There's also software engineering, there's information systems, there's information technology, there's computer engineering, and there's a number of newer specialties such as game design and data analysis and so on. So these are all recognized disciplines with official, well-established curricula, and they have different kinds of outcomes. And this is what we focus the booklet on. Our research that Michael alluded to earlier was initially focused on, do students actually understand these distinctions? Well, the answer is no. It's in fact, often computing professors didn't necessarily understand them as well. So clearly, if you're a counselor, your clients need help in finding the best path to computing. You can't just send them to computer science. And so we had this idea of a metaphor for thinking about these disciplines, and it revolved around cities. And let's say when you go and you travel and you visit a city, you might wander the streets and look up at these new buildings that you haven't seen, and you might think, oh wow, you know, this is the city. But really, it's not necessarily the outside. They're important, but it's actually what's happening inside those buildings is what really matters. And within computing, what actually happens is maybe a little bit more like this. So of course, this is stock photograph. It's not everyone's not smiling.
This is pre-COVID. That's right.
Yeah, that's right. It makes us all feel a little. Oh well.
We'll get back there. We'll be together again. It'll be okay.
Yeah, that's right. So what I'm going to do now is just spend a few moments and talk about the 5 key disciplines in computing: computer engineering, computer science, information system, information technology, and software engineering. So information systems is going to be as you can see, is one of them here. But what this slide shows is that we took this approach of having kind of an outside view and an inside view. The outside view is the disciplinary perspective. Like, what does the ACM say this discipline is all about, right? So back a few slides, we saw the outside of the building, started to get a sense of what does the rest of the world think about this discipline. But it's also the inside view, which is kind of important. Here was based on our research and our reading about, well, what are people in the field in this particular discipline actually doing? And we kind of hope that this provides to clients. We use this in our department all the time to show prospective students kind of what are the differences between we have 2 programs in our university, and students can look at this. Well, the idea here is that your clients can do the same as well. So for instance, with computer engineering, we kind of did a nighttime, because electricity is a big part of what these things do. It's more focused on the hardware, focuses on theories and principles. But what does an engineer actually do? Well, each of our disciplines, we have a little avatar who kind of explains the disciplines. And we have some things here about, well, what do they do, right? They focus on a variety of kind of engineering tasks. Each of these disciplines has overlaps with other disciplines. So the idea is that we have the different avatars for different disciplines say, oh, you know, we do some of the same things, but we do it in this way that's different, and so on. So for instance, computer science, well, computer science we kind of is more focused on theory. So they, for instance, focus on new ways to use computer, designing software architectures, effective solutions, and their theoretical background helps them in this measure. It's a bit of a fairground, if you will. But what do they actually do? Well, inside, well, they might take on challenging programming tasks. It's very mathematically oriented. This is why computer science isn't necessarily the best choice for a lot of clients, because it's very, very mathematical. And not every person interested in computing is going to have either the inclination or the background to really succeed in computer science. So there's a really, really wide range of sorts of tasks that someone in computer science might do. And computer science has overlaps with a lot of other disciplines, for instance, software engineering, information technology, and so on. Information systems is much more business oriented. So the idea here was to try to visualize this as a kind of a bridge between the technical and the business. And computer information systems programs tend to have a lot of variety. So depending on where one looks, an information systems program might have a real solid technology focus, but in another scenario, it might be much more business focused. What does an information systems professional do? Well, ideally, they're doing tasks that are combining their business and their technical knowledge. So there's a wide range of, again, they might act as an interface between users and experts. They might be training. They might be doing very technical but applied things, which is pretty similar to another newer field, which is information technology. Information technology is kind of tricky because often an information technology program might not actually use that label. It might have something quite different. But information technology is much more hands-on. It's much more focused on sort of the practical applied. So we decided to use a kind of a city view here that encompasses kind of all aspects, from the rural to the commercial to the industrial. What does an information technologist actually do? Well, they're focused on supporting these infrastructures. So they might be doing help desk type work. They might be using their combination of technical knowledge and practical hands-on to help support an entire organization. They might do their security infrastructure. In a sense, I kind of tried to show multiple floors here, because an information technology might cover from the infrastructure up to the operations. And then finally, there's software engineering. Sometimes software engineering is housed within computer science. Sometimes it's housed within engineering departments. It's much more process and engineering oriented, such as covering reliability and maintainability. They learn best practices for engineering, a focus on teamwork and project management. And in terms of what someone might do, well, we tried to show a sort of an assembly line of software here, just sort of like, and this inside view of everything. So they're using their special engineering design techniques. They might typically be supervising developers. They're looking about testing and usability. And again, the engineering perspective allows them to look sort of inside complex software systems. All right,
Okay,
Janet.
and then, well, I'm getting some really neat questions in the background, so I appreciate that people are already putting their questions into our little field here. Randy, one of the questions that came up was from Carolyn, and she's asking about current IS professionals. Could they use that booklet, the pages that you had there about IS, about how to leverage that skill set in other fields? You talked about the connection with business.
Yeah, well, that's an interesting thought. Like at one level, we designed the booklet thinking mainly about prospective students and counselors. But interestingly, the booklet has a kind of self-reflexivity, a way of sort of understanding one's own discipline, and like, oh, this is what I do, or this is what I can do, or this is so. Yeah, I guess to come to that question, I think it could be used in that kind of way.
That's neat. Okay, this page that you've designed, I love this as a counselor. And if I had to print off one page for a prospective student or someone thinking about switching into this career, I love these diagrams. This was adapted from the ACM discipline review booklet. Randy made it into a really usable system for me. On the one side, it talks about 5 different types of activities you might be doing in these different fields, whether it's organizational issues, application technologies, working with software and software methods, whether you're going to be doing more system infrastructure or working with computer architecture. So those are the 5 different things on the left-hand side. And then at the bottom, there's an array from being more theoretical to being more practical. So you'll know that there are some of our clients who really want that theoretical learning. They want to understand the science. I'm going to be looking more of the skew on the left-hand side. There's others who want more application, more practicality, hands-on, want to see things working in the field. So these different computer disciplines have different blob diagrams that are really, they convey a lot of information very quickly to our students. So I love those diagrams, Randy. And then underneath it, the close-up you were about to do there of the different sample programs, it gives an idea of the different courses you might be taking. We had a question about working with systems testing or looking at different, more, like Randy said, maybe more mathematical type of courses. This will give a quick overview of the courses that are really core to those different disciplines. Some sample programs you might take. Some of them are college oriented, some are university oriented, and then other pathways to get into this career for someone who might not want to take a 4-year degree or a specialization, but would like to get more literate or become more involved in these different disciplines. So I really like these pages as teaching structures. One of the questions we had here was about someone who doesn't want to necessarily go into a big discipline, but is interested in one of the fields. Either maybe you could talk a little bit about the like gaming and other kinds of disciplines you talked about, or areas in computing. And then what about the person who doesn't want to become a specialist in these areas, but they want to get better at using technology? Is that different than a computer discipline? If I want to learn how to do spreadsheets or learn how to work with Word, how to do a webinar, those kinds of applications, is that different than being in the discipline per se?
Yeah, I would say that it like using, learning how to use X or learning how to use Y is definitely different from these disciplines. That's probably more specialized training in a specific application, either through some sort of online thing. Like, so someone, I don't know, might want to learn and get better at, I don't know, Excel, because that's they want to be able to put that on their resume. I mean, that's something different. That might be something you'd look into, like with continuing education or something like that. But that segues nicely into the next slide. Is that the booklet? The core part of the booklet is the 5 principal ACM disciplines, but there's all these specializations. We looked at, we briefly, as you can see, looked at 6 of them: bioinformatics, network technology, cybersecurity, data science, game development, and media design or web development. These might be specializations within a traditional university program, for instance, though they're often sort of other pathways into these other disciplines quite often. So through colleges, through sometimes online certificates and so on. So we we kind of provided at least a little bit of some example samples of ways that one could get into this. So for instance, if we took a look at game development, we only say a little bit about it, but we tried to show that for each of these specialties, there's often 4-year approaches, 2-year approaches, or even 1-year approaches to these specializations. There's an arrow there.
Randy, I'm getting so many compliments here about what a great career planning tool this is and how beautiful it is. I'm excited. Thank you, everyone.
Yeah, so when you talk about the computing discipline, it's like a monster with organized tentacles, multiple organized tentacles. You can approach the computing discipline from various pathways. Some of them are longer than the others. If you look at the diagram on your screen, you see that from high school, you can go through online courses, you can take some certification programs, and finally become a computer person or a computing professional. You can also go through degree programs or college programs to become computer professionals. All we want to show here is that there are several ways by which you can become a computer professional. And it doesn't matter where you started from. The key thing is that you want to become a computer professional and you find a viable pathway to becoming a computer professional. In the same way, when you become a computer professional, it doesn't stop at the job that you started with. You can also move through different pathways to attain your career goals. You can start at a lower level and navigate through the ranks in the same career, or you can change careers between computer disciplines along the way. Now,
so I'm just going to pause you there, Michael, because we had a question about that, about addressing career changers that are looking there. They've maybe done one kind of career and now they're looking to augment or change into the computing disciplines. And I want to just highlight that you're saying that's possible and common.
It's
Indeed.
possible. It's possible. It's common, and it's kind of simple. Because you can take some online courses, you can go to boot camps, you can take certificate courses, and so on and so forth. And the number of people who started out in other disciplines just need about 1 year training or even less. And just the interest, you can also grow that on the job. The interest can also lead you to a different pathway in the computing career.
Indeed,
So,
and it is just to interrupt Michael for a second. It's what made sort of creating this booklet like tricky, right? Because there's so many, there's so many different paths to get to a given job. Like there's so many different job titles, right, Michael?
yeah.
And then there's all these different pathways. So I can't imagine, Janet, just how complicated that must be for a counselor to sort of, tell a client, hey, like there's a lot of different routes. And but it also means that like it's exciting that way, right? There's it's not just oh, do X, boom, done, next client please. Like it's a real there's a lot of interest and interesting ways that one can get to something.
Well, it's so true. I think that's why this career field is so exciting, is it's an individual answer for each person. It also makes it more overwhelming. So having a booklet like this so that I don't have to be an expert on these disciplines is so helpful, you guys, that to be able to lay out these different possibilities for clients and places for more information. I'm seeing there's comments here about using it in thousands of opportunities with young people. There's a labor analyst on our webinar today who says they've used it with over 1,000 youth. They would love to see it on the Jobs Canada website. It's just so useful, and it's kind of it's quite beautiful to look at and hold in your hand. And then the online version is gorgeous. Can you say something about micro credentials and taking courses? It sounds like in some countries those are very popular. Does that happen in Canada? Do we see these micro credentials as something I can add on to my resume or my portfolio?
Yeah, like if as Michael was mentioning these work pathways, right, Michael? Like these are in a sense like these, networking certification and so on. These are like there's lots of kind of micro certifications that one often does in the course of one's career, right?
Yeah, and this next page, can we have the next slide?
Why not? For you, Michael, anything.
Yes, thank you. Thank you, Randy. This is my favorite page. Okay. This is my favorite page, and a number of career counselors at the CERIC conference, a number of people approached us and said this page is absolutely useful. So if you don't know anything about all that we've said, please focus on this page, because a number of your students come around and say, "Oh, I want to become a data analyst. I want to become a data analyst." So if you want to become a data analyst, what aspects of computing can lead you to becoming a data analyst? Okay, and that's computer science and information systems. Some other person comes and says, "I want to become a project manager." So how do I become a project manager? As a career counselor, you can just turn to this page and say, "Oh, well, where is project manager?" Boom, this is project manager. You can become a project manager by doing taking any of the computing programs. Either as a computer engineer, you can become a project manager. Computer scientist can become a project manager. Information system specialist can become a project manager. IT and software engineering. And so we've lined up, and that's the beauty of this booklet, lining up the common computing careers, okay, and the disciplinary pathways to those computing careers. If you want to become a help desk support specialist, computer engineering and IT could be the pathway to that. And in some ways, you need to take some additional training. You need some additional training to be able to qualify you for those kinds of careers. For example, if you want to become a data analyst, then taking statistics as an additional training will be of immense value. So this page is very valuable in advising your students. So if there's any page that you want to print out and have it posted on your office wall, it will be this page.
I love we all have our favorites. I love that.
Oh,
Michael,
yes, I like this. I like this page. So you can
There is
just
a
point to
question,
this
Michael.
page and tell your students, please take a look at this. Oh, what do you want to be? And here is what you have to do in order to become that.
So Michael, I've got a question here about someone who's working as an employment counselor with internationally trained professionals. And they're asking a question about transitioning from one career to another. And they actually ask about business analyst specifically, which is the first row on this, this document here. So if someone is looking to transfer from a more technical role into that business analyst type of role, what I like about this is that you're saying we can use this as a guide to help people see what they need for additional training. How else do you use this page to help people look at transitioning from one career to another?
Apart from the additional training component of it, you'll be able to see the intersection between one computing discipline and another. So if I'm, for example, in IT and I want to become something in the area of IS, say a data analyst, okay, I understand the fact that IT and IS has some level of intersection. And so what you now do is to look at some of the courses in IS that relate to being a data analyst and focus on taking those courses. You can take those courses online. okay? You can attend short programs, take those courses, and it helps you to become a data analyst. So understanding the intersection between one discipline and another is another very useful aspect of this page.
Awesome. Okay, let's
And one
move
of
on to
the-
talk a little. Oh, sorry, Randy, go ahead.
Well, one of the things I was going to say is I think the booklet does have an orientation that's maybe principally focused on younger people starting out, right? We've tried to add overlays to help people who are transitioning from one career to another, but that's where things get really more complicated, because often someone's not interested in doing a new degree. So these in front of us, you see the 5 different disciplines, which tend to be mapped onto degrees. But for someone who's not interested in that, that's where things get, it's so broad, we couldn't possibly cover everything, and that's really where the counselor or the advisor has to do all that extra work. Sorry, Jack, you were about to say.
And in addition, once you have this page, you ask the next question, which is on the next slide. And that question will be, what kind of computing work are you interested in? That's the question that you ask your clients. And once they tell you that, then you can refer them to that list of computing careers that we have listed there. But it's not exhaustive, because the computing profession has grown so large and it keeps growing by the day. With the COVID experience, I must mention COVID again, it's growing again. And people are thinking, how am I going to go into the discipline of remote enablement? How do I enable processes from remote locations? That's becoming one of the new careers that you can pursue in the computing discipline. So how do you do that? And will you do that by just learning the technical things like Cyril did for us and made this seminar a wonderful one? Or are you going to learn the psychology of dealing with individuals who are working from home, who have to take tea intermittently and all that? So those are some of the things that you have to consider when advising your clients. And next we went across Canada to look for people who have succeeded in the computing careers. We went across provinces and even got to the United States to ask questions, to ask them, how did you get there? What's been your experience working in the field that you're working in now? What advice do you have for young people that are going into these disciplines? And the beauty of the alumni stories that we have lies in the level of diversity. Diversity in terms of the discipline, the career that they are in, and diversity in terms of the pathways. You see someone who was a history graduate becoming a CTO of an organization. You see someone who came in from the field of philosophy, becoming a game developer, and so on and so forth. So the computing career, it's so huge that anybody can come in, okay? But some of the key things that we learned from the alumni include the fact that the students will have to develop general problem-solving skills. They have to be adaptable. It's not about the technical skills, but the students should understand, your clients should understand that it's about being adaptable, because you can change from one computing career to another. There are various pathways you can navigate the computing world. And for you to be able to do that, you need to be adaptable. It's not just about being able to code in one programming language or the other, but being able to fit into different situations and work scenarios that you find yourself. And it is also important to let your clients know that the computing discipline is a big career that has a development process. And that development process requires patience, it requires curiosity, it requires your ability and willingness to fail and stand up and continue focusing on the goal. So the alumni stories are a very valuable component of this booklet, which our students, our clients will relate with, because these alumni stories they cut across age brackets. You have young people, you have older people sharing their experience, sharing their stories, and you have people across gender, across all forms of diversity, sharing their stories. So students can relate with these alumni stories as a way of finding themselves in the computing world.
Nicely said, Michael.
So as part of the booklet, we've put together a reasonably straightforward little website called computingcareers.ca. It's got some stuff from the booklet, some more images, and so on. There's also links to the CERIC page, where you can download it. We had the URL up earlier, but sometimes I think computingcareers.ca might be a little bit easier to remember. You can click the download, and it just takes you to the CERIC page where you can then download the booklet. Just a few weeks ago, the ACM Inroads, which is the sort of their premium kind of a worldwide magazine devoted to computer education, published my article about the booklet and the discipline. So I guess that's there.
Well, just to pause on that, that's such a great conversation though, Randy. And as a career counselor, to start to understand how to apply these things, about the background, and then to have this opportunity for such a premier publication, like it's congratulations on that. That's awesome.
Yeah, well, I'm hoping it'll expand the booklet's reach much more so into the United States and outside of Canada for sure.
Yeah, and I think a number of universities outside of North America are appreciating the content of this booklet.
Absolutely,
and,
yeah.
It would be nice to get it across to all over the world. We've had people downloading from Australia, from Africa, from all over the world, and soon everybody that is going to be studying computing will need this booklet.
Let's hope so.
Okay. I love this. Now we're ready for questions. I think I'm the little one in the middle, so I'm gonna fire off some questions for both of you. So one question I have from Fred is about high school students. Do high school students, would you recommend that they take these optional computer science courses as their electives in high school, or would you say a foundation in math is more important, or both, or neither?
Well, certainly maths. Having a decent enough mark in your high school math is going to give you options. So absolutely, the math is going to be important. As for high school computer science, it's not essential. One of the things that's an unfortunate reality for decades and decades is that the very first computer programming course tends to have about a 50% attrition rate, which means about half the students go, no, thank you. I want to do something. This isn't for me. Taking the computers, and that's great. Like I always find that as a success, not a failure. People just realize, oh, this isn't for me. So taking the high school computer science, Fred, can give one a little bit of an insight ahead of time. But as we tried to show you, programming is not computing, right? Programming is the computer science, if you will, side of the discipline, and the high school computer science class can give you some insight into whether you are going to like university computer science. But again, there's all these other computing disciplines that are not programming oriented, and so yeah. I'm not
and
sure
many
that
other programs also require math. That taking
absolutely.
calculus was part of my core first year. Okay, Michael, Gulshan's wondering about courses or jobs that are in demand in the next 5 years. If you could put on your, I don't know, crystal ball, what do you think is going to be most in demand for employment in the next 5 years?
It's interesting because I like that question, because here in Calgary, I'm part of a team that's developing a framework for a learning city. And the need is, the essence is to develop a set of programs that will be in high demand and create an ability for students to fit into that. Currently, data science, data analytics is a big thing because everybody is going big data, big data, big data. Yeah. But I also know that with the COVID-19 experience, things may change quite quickly. A number of schools are beginning to talk about network specialists, IT technicians, support workers, and all that. And it is important to note that a bunch of big organizations are now beginning to think about the possibility of their employees working from home because it's going to save them money. Mm-hmm. So it might bring a new wave of individuals that are interested in remote working, in remote communication. So telecommunications might become very important soon. The key thing is that the computing discipline is very fluid in terms of job opportunities. Today is data science. Yesterday, it may have been database administrators and web developers and so on and so forth. So for every individual, it is important to have that ability to adapt and restructure and retrain yourself to get into the new wave of jobs. But that analytics now,
and that's the advantage, Michael, of a university experience, right? Is sometimes we have students say, "Oh, how come I'm not learning X and Y? Because X and Y are really hot right now," right? And it's because you're trying. Part of what we try to do in an educational curriculum is to create a foundation for change, right? So as the profession changes, you can adapt to it, right? And that's potentially the one gotcha, I think, about students or prospective students or clients who want a very specialized bit of training to help them, you know, because they think, oh, this is going to be the career, this is what's going to be hot in the next 5 years, right? And that might make sense if you already have a background, right? You have that foundation, but it can be kind of dangerous to, like, I wouldn't counsel an 18-year-old to try to craft their educational experience based on a prediction of a specific, you know, career outcome.
Job. Yeah, exactly.
Yeah, one job 5 years from now.
Well, it's sort of like that pathway you talked about, that it's not the pipeline. We're not in a pipeline system. We're trying to teach people how to learn and how to adapt. And that's true for our college colleagues as well, that being in that immersive experience of learning to learn, then you get adaptive. Randy or Michael, what's the difference between a software developer and a software engineer? Many of us in counseling have heard this used back and forth interchangeably. Software developer, software engineer.
Well, at one level, they are often used synonymously. So especially, I guess, casually, within software development circles, I'm kind of a specialist in web development, and web developers will often use the term engineering to just refer to programming and analysis. So they are synonymous at one level. But Michael, as you might speak to the fact that they're also separate when it comes to disciplinary identities as well.
Yeah, a number of software engineering programs are now housed in the engineering faculties. And the reason is that okay, simply defined is the application of engineering principles to software development.
Mm-hmm.
And software engineering deals with a large and complex software that address situations that change quickly. So they try to specialize it, but their software development is an aspect of software engineering.
Okay.
So it involves more than software development. It goes into user requirements analysis, relationship management, and a whole
On and
bunch of
on.
issues.
Okay, well, in the interest of time, friends, I'm going to invite CERIC to come back just to help us close off. I will just say that we don't have an assessment tool, although what a great question Melissa asked. Is there a way to assess our interests? We don't quite have that from this document. Or about trying things out. We had a question, oh, this one was from Melissa, about can students try out different programs before they commit? What I'm going to really recommend is that you go through the booklet, help students to get a feel that inside, outside of these different disciplines and different jobs, go through the alumni stories that really bring it alive. These are real people who actually have these actual pathways that were interviewed by Michael and one of our research associates to help people see like a flavor of these different pathways before they go into it. As a career practitioner, I found this super useful with my clients. Michael and Randy, final words before we pass it to CERIC. Michael?
I just want to say it's been wonderful having over 500 people in attendance, and I do hope that this experience, this webinar, will make a whole lot of difference in your helping your clients navigate through the computing career or careers. Randy.
Yeah, and don't, like, even I think Michael and I, as experts in this field, I mean, I've been teaching in computing for, I don't know, 23 years. And even still, like, there's uncertainty in my mind sometimes about, you know, it's like, you maybe you're at a party or you see someone, they say, oh, my son wants to go into this or my daughter wants to do that. And it's not always easy to really assess this. I think it's okay to feel a little bit of uncertainty in this area. Hopefully the booklet can help somewhat in that.
I'm sure it will. It already has with me, and as we've seen from comments from thousands of others. And thank you for making this a free download, CERIC, for all the support you did in the background. And CERIC, thank you so much for having us today.
No, my pleasure, and I can confirm that yes, the guide will help for sure. Janet, Randy, and Fair Michael, thank you to all of you for this great and very interactive presentation today. I feel we got a good overview of the key learning of the new guide, and you addressed a lot of questions, so you did a good job here. And thank you all, by the way, for your great engagement today. It was really terrific to see all the questions coming. So I believe we feel now more familiar with the computing career and discipline. So thank you for having shared your knowledge and expertise with us today. Now you may want to dive more into the work and research our presenter have done. So you can learn more about the computing career and discipline guide, including downloading your own free copy at ceric.ca/computing. You may also want to continue your learning journey with other webinars, and I'm happy to say that we'll be back tomorrow, Thursday, June 18, for a free webinar with Yilmaz Dink on job search and career exploration during COVID-19 recovery, providing guidance to newcomers. So please visit our website at ceric.ca/webinars for more information or to register. And don't forget to subscribe to our webinar news to stay informed of new webinar opportunities. And now, before leaving us, please don't forget to share your feedback and future learning need with us in the survey that will pop up on your screen. And let me now close by thanking you once again, Janet, Randy, and Michael, for your wonderful presentation today. And thanking you all for your wonderful engagement. Have all a great day and see you maybe tomorrow.